This question, please, we have to carry on with functions as well. Thank you. Okay, so number 4, they told us that, thank you, AB is the diameter of the circle, but guys, do you notice that they haven't actually given us the center of the circle? They're just saying that AB is the diameter. Okay, so we won't be able to use angle at center or any of that stuff, but we can use the fact that it's the diameter, which I'm actually not sure. Did I use it? Yes, in the first, okay, yeah, sorry. So C is a point on the circumference, DC is a tangent to the circle at C, so we can use tan chord if we need to, and meets AB at D. So it's just saying that AB was lengthened and it is lengthened to meet the tangent. If DB is equal to BC is equal to A, so those two lines are equal, and BAC is theta, prove that DC squared is this whole thing. Now guys, the fact that there's a cos there should make you think maybe I must use cos rule. All right, possibly, that's something to look out for, but we need to get to DC. Okay, now what I wrote down, basically what I put in here, just obviously not for yours, what I wrote down is that if this is A, then that's also obviously A, right? And if this is, oh, angle C here is theta because of tan chord theorem, right? Are we fine with that? But then if this angle is theta, then that angle is also theta because of angles opposite equal sides, because it's an isosceles triangle. So then that is 180 minus 2 theta. Okay, and then from there I used cos rule, and that's actually all I needed. So I said BCD is theta because of tan chord theorem. Therefore, angle D is theta because of angles opposite equal sides. And therefore, that top angle is 180 minus 2 theta because of angle sum and triangle. And then I just used cos rule in this bottom triangle. So I just said DC squared is A squared plus A squared minus 2 times A times cos of the included angle. And I then simplified it from there. Talia, what did you want to say? Okay, Talia?
In the 75, why did the like in the second part, why is it 1 plus in the bracket? Why is it 1 plus cos 2 theta?
Because I used reduction formula there. 180 minus is in quadrant 2, and cos is negative in the second quadrant.
Oh no, sorry, I mean.
Yeah, no, so it's getting to that.
Plus
Yeah, so it's this, it's because of that. So because this is in the second quadrant, this part of the term becomes negative cos 2 theta, but this is all one term, right? So it's a negative times a negative essentially, which then becomes a positive. So guys, that is a common thing to get confused with there. This actually all is one term. So if that cos becomes negative, then you need to actually change the sign in front of the whole term, right? Because it's negative 2a squared times negative cos 2 theta, right? This is all one term. And a negative times a negative is a positive. Okay, so that all is one thing there. Then from there, they asked us to prove this. So do we notice that we just have a common factor of 2a squared, so you can take that out. Remember, when you take out a common factor, you divide each term by that factor. So 2a squared divided by 2a squared is 1. And this whole term divided by 2a squared is just cos 2 theta. And that is what they asked us to prove. So guys, you didn't actually use the fact that AB was the diameter. Yes.
Did you have to do a complete breakdown, like of 2a squared minus 2a with the minus? I just wrote the first line, then I went to. Well, not the first line. So I wrote the first line, then the second line, and the second line, and then I went last line. So I have.
So this is that. Yeah, that's fine. I don't think you have to have both of these lines. I usually would probably just leave that one off. Showing that it's a negative times a negative.
Or if you didn't do chemical theory, you could have done angle sum and triangle.
Mhm.
Be in.
Oh, with the 90 minus.
Would be 90 minus theta. So then angles on a straight line.
Is then 180.
So then B also be.
Yeah, okay, cool. In that case, guys, if you are using the fact that that one angle is 90, you have to say angles in semicircle. You have to add that reasoning.
So you didn't show that
Yeah, because I think they'll give a mark specifically for this to that. For showing the reduction formula, which turns it into a plus. So yeah, I do think you have to show either that line or that line. I don't think you have to show both of them. But yeah, with these prove that questions, guys, it's always better to show more lines as opposed to less, because yeah, you can't really just go from the first line to the answer because the answer is actually given. Yeah.
I was really confused because I had to do it the other way.
Mhm.
I was saying that BCA is 93
Yeah.
and then doing angles on the triangle.
Mhm.
So then CBA would be 90 minus theta.
Mhm.
Would that make like DBC also 90 minus
DBC would then be 180 minus 90 minus theta, which is then 90 plus theta. Because then you must put that in brackets when you minus in it. Because it could be that. All right, guys, is that fine? Then for 4.2, it was a different type of question where they just said if DC is now root 12 and A is 2, show that theta is 30 degrees. All right, so here I just took the thing, and guys, this is also the other thing. Remember that if it's the same as with your circle geometry. If they're asking you in 4.1 to prove something, but you can't prove that, then you have to use that thing in 4.2, right? So even in 4.1, if you didn't get to this, then in 4.2, you have to use what they gave you. All right, that's why they're giving you that information. That's why they're not just saying, write an expression for DC squared. Okay, because they want you to actually use that whole expression in 4.2. Okay, so I use that expression. I just subbed in 2 for A and root 12 for DC, right? Because this was DC squared, so it's root 12 squared. Then I just worked that out. That's 8, and this is 12. And now if we need to show that theta is 30, basically we have to solve for theta, right? And the answer that we're supposed to get is 30 degrees. So I divided by 8, which gave me 3/2. I minus 1, oh, sorry, which gave me a half. And then where is cos positive in quadrants 1 and 4? All right, are we in a triangle working with a 360 minus degree? No, so we disregard the fourth quadrant, just work in the first quadrant. So you're going to do shift cos of a half will give you 2 theta, and that is 60 degrees, right? That's how I got to 60. Cos to the -1 of a half. But the angle there is 2 theta. So to get theta, we have to divide by 2. Now, guys, that's quite a nice combination of trig equation and what's it called? Triangle rules. Yeah.
I didn't realize you just use parabolas, but if you wrote up the whole like equation for the parabola.
Yeah, it's fine as long as we're doing it correctly. Because obviously, if you're not doing it correctly, you won't get to 50. Yeah, but that's fine.
if you use like the two, so if you use like the semicircle and your DBC angle was 90 plus theta, and then in the other way it was 180 minus 2 theta. If you said 180 minus 2 theta equals 90 plus theta and then solve for theta, I got to 30. So would that be fine?
That's fine. Unless they said hence show that, because then they're forcing you to use 4.1, but they didn't say that in this case, so that would be fine. Yeah, no, that's fine. Good. Okay, guys, for the revision questions, you just had to do 6.1 and 6.2. So there is 6.1. So they just said use the diagrams below to prove that for 6.1 PS was this whole thing. Remember, I just asked you to put the 90-degree angle in there. It wasn't in the given diagram. So this is what we're trying to get, PS. So I started by working with, so that theta was given, but here we can see that this is an isosceles triangle. So if that is theta, that is also theta. And your reason is angles opposite equal sides. Then I said that QSR is then again 180 minus 2 theta because of angle sum in a triangle here. So 180 minus theta gives you that one. And guys, the reason for me calculating that angle is because I have the opposite side. So if I want to use sine rule, I need that pair, right? I'm trying to find the common side. Remember, that's what we're always doing when we have multiple triangles. We're trying to find the common side first. The common side is QS. I have now the angle that's opposite QS. I found it there. And then I have another pair of a side and its opposite angle because I calculated that one. So there I have my sine rule. QS over sine theta is x over sine 180 minus 2 theta. This is quadrant 2. And sine in the second quadrant is positive. So it's just going to change to positive sine 2 theta. And you multiply the sine theta on the other side. So we have the common side. All right. So that's one thing done. And guys, in tomorrow's test, if you don't know what to do, at least just get the common side. Okay. 99% of the time you will get marks for doing that, at least. Okay. Then we're working in this top triangle, which is a right angle triangle. So we can use sine, cos, or tan. We have that angle and we have the common side. We're trying to find the opposite side, right? So we're looking at that angle. The one that we're trying to find is opposite. The one that we have is the adjacent side. Opposite and adjacent is tan. So tan of alpha is PS over QS. Then to get PS on its own, remember that's what I'm trying to get. I'm just multiplying by QS on the other side. And then this was an easy one to do, guys, because we didn't have another fraction. It's just QS times tan alpha. So this thing times tan alpha. Right, in which case you would just put the tan alpha at the top of the fraction. Yeah.
If things easily kind of start with tan theta, just finding out the equation for PS.
Yeah. And then find QS and then sub it in. Yeah. Okay, any other questions, guys? All right, 6.2 was a bit longer. And you actually, I wanted you guys to see this one because now we were working with 150 degrees, which we actually haven't done before. So they wanted us to show that BD was equal to this whole thing. So again, we need to find the common side, all right? Now, if we want to use sine rule, I usually just check for sine rule first. BC over sine theta would be equal to A over sine 150. So we actually had everything that we needed to do sine rule straight away. We didn't still have to calculate stuff. So there we have BC. Remember the common side always, BC over sine of the opposite angle is A over sine 150. Now guys, sine 150, now you need to remember what we did when we did trig. You can write sine 150 as sine of 180 minus 30, right? Because if they're saying you must do this without the use of a calculator, they might not say it, but they might, all right? Then you need to be able to do that without the use of a calculator. 150 is the same as 180 minus 30. So we rewrite this angle in a way so that we can use reduction formula. Okay, and we did that when we did trig last term. 180 minus 30 is in the second quadrant. What is sine in the second quadrant? Positive. So this just becomes positive sine 30. Also, if they said without the use of a calculator, you have to then show your special triangle, right? In order to get the value of sine 30. Sine 30 is opposite over hypotenuse, a half. So you have A sine theta over a half. Now, when you're dividing by a half, that's the same as multiplying by 2 over 1. You tip and times, right? So this is the same as A sine theta times 2 over 1, which is 2A sine theta. All right, so I just thought that that was interesting, and we hadn't done an example like that before, where you actually are given an obtuse angle, and you need to rewrite it as 180 minus 30 so that you can use reduction formula. Okay, now remember we're trying to find BD. This is a right angle triangle here at the bottom. So we have that angle, we have the common side now, which is the adjacent side. We're trying to find the hypotenuse. Adjacent and hypotenuse is cos. So cos of beta is BC over BD. I want to get BD on its own, so I need to multiply it out and then divide by cos beta. And then the substitution was easy because this wasn't a fraction. This was just a, one thing, not a fraction. So it's just BC, so 2a sine theta over cos beta like that. Okay, any questions, guys? Unfortunately, I cannot give you the rest of the lesson just to study. We do have to carry on with functions. I'm sorry, I know it's not ideal. Luther, you need one of these. Who else didn't get this worksheet on Friday? Anyone else? Okay. Oh, sorry. Okay, guys, let's look at that worksheet. You might not have filled the whole thing in, but we're just going to go through the whole thing quickly. Okay, there we go. That's what my graphs look like. If yours don't look exactly the same, don't worry. We're just doing this to get a general idea of what's happening. So I told you in class you must sub it from -3 to +3, but unfortunately in some cases that doesn't actually give you enough points. So then I say if that happens, sub in more values so that you get a nice symmetrical kind of graph. So the first one, the one that they gave us was y equals x squared. Okay, with a turning point of 0, 0. Then we had to draw in y equals x plus 2 squared, which is this blue one over there. Then we can see that y equals x plus 2 squared. If I just compare it to the original one, it has just moved 2 units to the left. And guys, remember, I did say this on Friday, but I'm going to say it again. Remember when we did trig graphs, which you guys did quite well in, I felt. When it was an x plus 30, the graph moved 30 degrees to the left. Same thing here. If it's an x plus 2 squared in brackets, the graph is going to move 2 units to the left. Okay? Same thing with all the graphs. Yes. Then we did x minus 1 squared, which is the little purple one here, or pink. That one there. Now, if we compare the black one and the pink one, this one, the x minus 1, moved 1 unit to the right. Just like with the trig graphs, when it's an x minus, it moves to the right. Then the last one had a sideways shift and an up shift, all right, which is the kinds of graphs that you need to be able to draw. So that is the orange one. This was y equals x plus 3 squared plus 5. Now, if we just look at the turning points only, but guys, it actually happened to every single point on the graph. It's just easiest to look at the turning point. If we look at the turning point of the original one, which is 0, 0, to get to that new orange one, it's moved 3 units to the left, which we expect because it's an x plus 3. So it should move 3 to the left, but then the plus 5 makes it move 5 units up. Okay. I tried to summarize that there at the bottom. You can just add that last line. You wouldn't have written that. That is the actual standard form that we're going to work with. Turning point form, actually. So I just listed the 4 graphs that we have and what their turning points actually are. All right. So y equals x squared, the turning point was 0, 0. Because they're asking here, comment on how the coordinates of the turning point in each function relate to the equation. So I just summarized the turning points first. If it was x plus 2 squared, the turning point was -2, 0. If it was x minus 1 squared, the turning point was 1, 0. And then when it was x plus 3 squared plus 5, the turning point was -3 and 5. So guys, this is actually what we call turning point form. It's a second form of the parabola equation, which you haven't done before. Turning point form. And it is called turning point form because you can see what the turning point is going to be by looking at the equation. Ooh, that's here anyway. So I wrote it just in general form with letters, okay, so that we can generalize it. If the equation of a parabola is written like this, and guys, notice that I put the A outside the bracket. Okay, do you remember when we did trig graphs and we had an x plus 30, the k value was always in front of the bracket? You guys remember that? Right? If we had like a 2x plus 30, then we would have to take the 2 out. It's the same thing here. All right, the A value, we'll discuss just now what that means again, but the A value is outside of the bracket. Then you have your x minus p. Now guys, if it's minus p, then your turning point is going to have a coordinate of positive p. Right? So the sign of the value inside the bracket is different from the sign of the value in the actual turning point. Okay, that's why I made it x minus p in the bracket and then positive p in the actual coordinates. And then whatever your q value is, this is the same letter as last year. You did use q for shifting up or down. Whatever that q value is, that is the y value of your turning point. But you don't change the sign for that one. All right, it's just the x one that changes its sign. How do we feel about that? Does it make sense? It's similar to the stuff that we did with trig graphs. Okay, it's just not obviously different type of shape. Okay, then for number 3, they asked us to rewrite each of the functions in the form y equals ax squared plus bx plus c. Guys, this form is still called standard form. So just add that there. If they're talking about the standard form of a parabola equation, it's still y equals ax squared plus bx plus c. Sorry, let me zoom in a bit. I should have done that earlier. It's quite small. Yes. You can just go straight to okay, so we have turning point, which is new, and we have standard form, which is what we did last year. Now, what they're wanting you to do, guys, to go from turning point form to standard form, I think it should be quite obvious that if you have a bracket squared and you want to go to ax squared plus bx plus c, you must just multiply the brackets out. Okay, so I just wrote that middle step down where you write them next to each other. You can leave that out if you remember how to square a bracket. Okay, but remember that middle term, right? Here behind me, very important. You must not throw away the middle term, right? You can't just say that it is x squared plus 4, because it's not. It's x squared plus 4x plus 4. Okay, so those would be the standard forms of those 3 graphs. Then they're asking, if we now are looking at the standard forms of the 3 graphs and we're comparing them to the actual graphs, what do we notice? Now, guys, I want you to look at the, where's that thing now? I want you to look at the C value. Oh, they're actually asking, sorry, the significance of the C value. So we're looking at the constant term in each of those equations. And we're seeing where does that actually feature on the graph? All right, so for the first one, 4, and then 1, and then 14. Let's take a look. The first graph, which was the blue one, 4 was my y-intercept. Right? For the second one, which is the pink one, 1 was also my y-intercept. And for the orange one, 14 was also my y-intercept. So guys, when you have a graph written in standard form, the C value is always the y-intercept. Can anyone remember what is the actual calculation that you do to find the y-intercept of any graph? You have to make x equal to 0. Now guys, if you have this and that, if you make x 0, what is x squared? What's 0 squared? 0. What's 4 times 0? 0. So what's left? The C value, 4. All right. So if you forget that C is the y-intercept, that's okay. You can still make x equal to 0. You'll get the same answer. Then they were just asking in terms of the shift that's happening. Comment on the effect of P in a function written in this form. And you must consider when P is negative and positive. So if you have X minus P, but P is positive, then it's going to look like that, right? It's going to be X minus P because it's a positive number now. So if P is 1, for example, it will be X minus 1. Then it shifts P units to the right. But if P is negative and you sub a negative P in there, it's actually going to become X plus P, right? And then you're shifting to the left. So don't worry about that too much if that confuses you a bit. It's just a summary. If you have an X plus, you're moving to the left. If you have an X minus, you're moving to the right. Okay, that's what we're trying to get across there. And then for Q, if Q is positive, you're shifting Q units up. If Q is negative, you're shifting so many units down. Okay, we are going to summarize that now in a proper note. So just make sure that you copy that down quickly, and then we're going to do a note on parabolas, and then you're actually going to draw the ones. You might have started drawing them in class, but then I said you don't have to finish it for homework. But if you have, then you won't have homework for Wednesday. This will be homework for Wednesday now, right? The parabolas that I'm going to give you. Just want to check quickly which topic this is. 5. Okay, guys, are you done with that page? All right, topic 5, functions. It's topic 5 in the textbook. All right, it's obviously not the 5th topic that we're doing this year. Guys, I know you're tired. I know you have a lot going on. I know that you're doing the test tomorrow, but functions is a very important topic. It really is unfortunate that we're doing it at the end of the year when everyone, I mean, even me, I'm exhausted. But yeah, it's going to count a big percentage of your final exam mark. Let me actually show you guys something that is quite nice that you might want to refer to in the future. All right, thank you. Now guys, parabolas are known as, thank you, quadratic functions. All right, so they might use that word, that term. So a parabola is actually a quadratic function. And the reason for that is because it has an x squared in it, or it has a bracket squared, which when you multiply out will give you an x squared. All right, so now guys, there are actually 3 forms. We've only looked at 2 of them, but we will discuss the 3rd one quickly. So there are now 3 forms that you need to be able to work with. The first one is standard form. Let me just underline this because that is a heading. All right, the first one is standard form, which is y equals ax squared plus bx plus c. And what did we just say about c when it's written in standard form? C is the y-intercept, yes. So c is the y-intercept always. So the coordinate of your y-intercept will be 0, and then c will be that y value of that point. All right, the A value, guys, for parabola, remember, always tells us if it's an upwards facing parabola or downwards facing parabola. So if A is positive, then you have an upwards facing parabola, right? The number in front of x squared, if that's a positive number, then you have a positive parabola, an upwards facing one. But if the number in front of x squared is negative, then you have a downwards facing parabola. Now guys, remember when we're drawing any graphs, they always say you have to label all intercepts with the axes. All right. Now a parabola will always have a y-intercept. It doesn't always necessarily have an x-intercept. We can look at some examples like that. But to find the x-intercepts, can anyone remember how we do that? For any graph, to find the x-intercept of any graph, we make y equal to 0. Same thing here. So if you're having to draw a parabola and it's given in this form, to find the x-intercept, you're going to have to make y equal to 0 and then solve for x. Now, if you do that, guys, you're going to get something that looks like this. Ax squared plus bx plus c is equal to 0. And guys, we spent about 3 weeks at the beginning of the year discussing various ways of solving quadratic equations, right? Ax squared plus bx plus c equals 0, that is a quadratic equation, right? So you can solve it by factorizing, possibly, or what else can we use? The quadratic formula, right? You can always use the quadratic formula. So if you're not good at factorizing, don't waste your time on that, just use the quadratic formula straight away. You'll get your x values and those will be the x-intercepts. Yes. Right, so here I'm just going to say, remember the quadratic formula. Okay, you can still use that to solve for x because it's a quadratic equation, so you can use a quadratic formula. Or you can factorize, make each bracket equal to 0 and solve. Now guys, the thing that we can't see when we're looking at this form, at standard form, is actually the turning point. And you have to always, when you're drawing a parabola, you have to draw or plot the turning point. Okay, so there is a specific formula that we use to calculate the turning point. So I'm just going to write here for the turning point, we'll just use TP as an abbreviation. The formula is x equals negative b over 2a. Right, that is the formula that we use to find the turning point. Guys, that gives us the x value of the turning point. And where's that b coming from? What is b? It's the coefficient of x, all right? So you're going to take negative b. This is almost like in the quadratic formula, right? We start with negative b. Okay, so we do negative b, but then we divide that by 2a, which is also what we divide by in the quadratic formula. All right, yes? Without the square root, yes, exactly. Okay, so negative b over 2a. Guys, that will give you the x value of your turning point. But remember, a point has to have an x value and a y value. So once you've found your x value, you're going to take that x value and sub it into the equation of the graph. And that will then give you the y value of the turning point. Okay, so you first calculate x, then sub into original equation to get y. And once you have your x and your y, that is your turning point. No, this is not in the formula sheet. So you can find it online, like I showed you now. It is available online. It's in that document. And also for all matric pass papers, the formula sheet is there as well, but it sometimes changes from one year to the next. Okay, guys, that is basically all of the things that you need to know if you are asked to draw a parabola that's given in standard form. Sometimes they can ask you to write this equation in standard form in turning point form. Does anyone have an idea of how we could do that? How can I, just hold on. How can I write an equation? What can I do to it? If it's written like this, but I now want it in turning point form. Remember, what is turning point form? A bracket x minus p squared plus a number. Jasper?
Would you, so first would separate A, push it outside of the bracket.
So take out A as a common factor, yeah?
X plus B times X, and then close out the bracket, that's squared, and then plus C.
So not exactly like that, but you are on the right track. Does anyone want to pick up from there, James? Take out a factor of X. So we need, the thing is we need no X in front. We just want an A, we just want a number in front. We want the X to be in the bracket squared. Okay, but you're also on the right track. The problem with that is just that we don't have an X in the last term, so we can't take X out as a factor from all of them. Okay, yeah, so I see what you're saying, but then we're just gonna have an AX and then X plus B. We want that bracket to be squared. Let me help you guys a bit. All right, we did a specific method of introducing a bracket squared. If you have a quadratic equation, how to change it up so that you end up with something and then a bracket squared. Yes. Completing the square. Good. Do we remember? Yeah, do we remember? I think it was maybe the first lesson, the second lesson of the year, we did completing the square. Don't worry, I'll do an example with you. Guys, we did it with circles as well. Do you remember? With analytical circle geometry, we had to complete the square for X and Y. Does that ring a bell? Right? If the circle equation was given in standard form, which was also just a bunch of terms, then to get them in the bracket squared form, we had to complete the square. Okay, so I'm going to write here just a little sub note to go from standard form to turning point form. Complete the square. But guys, we're just summarizing, don't worry, we will do examples of all of these things. Okay, that's standard form summarized. The second form is turning point form. So number 2, turning point form. No, we'll keep it for next year, then sell it the year after. Okay, turning point form. Now this form is slightly different. You put the A and then you have your bracket X minus P squared and then you have your plus Q. Yeah, some people do that. Some people have like an A5 book for all their notes and then an A4 book for exercise. Okay, now guys, notice that there's no B or C value here. All right, we are not going to say that Q is our y-intercept. Okay, in some cases it might be, but not always. All right, so we're not going to say that. So here, when it's written in turning point form, you can't just tell what the y-intercept is straight away. Okay, but you can see what the turning point is straight away. So you don't have to do this whole calculation. All right, you don't have to do x equals minus b over 2a and then sub it in. You can see what the turning point is from this formula. So this is now what you need to remember. Let's write it on the side because it's the most important part. The turning point is always the same value that's in the bracket, but with a different sign. So if it's an x minus 1, your turning point is going to be 1. If it's an x plus 1, your turning point is going to be negative 1. All right. So the sign in the bracket is always different to the sign in the actual point. I'll be with you now. And then q is your y value. Yes?
No, didn't you say our y-intercept will be if you put 0?
Yes. Yeah, I'm going to write that down now. Yeah. But then this is going to give you negative p squared, not a 0.
Yeah.
Yeah.
Maybe
Yeah, negative p squared, which then becomes positive p squared. Yeah. Okay, so guys, turning point, are we fine with that? Right? You can read the turning point off. And this is similar to when we did the circles, all right, analytical circle geometry. We got the center of the circle in a similar way. You guys remember we had an x minus a squared and a y minus b squared, and AB was the center of the circle. All right, same thing here. PQ is the turning point. Now to find the y-intercept, we're now just going to have to use our almost like our old method, which is to make x equal to 0. Sub that into the equation, work it out. Right? So if x is equal to 0, then y is going to be a times 0 minus p squared plus q, whatever those values are. All right, obviously p and q will be numbers. You can then type that into the calculator, and a will also be a number. You can type it into the calculator, or you can work it out in your head, and that will give you the y-intercept. Okay, you're actually going to have to do a calculation for that one. Yes.
What would be given for equations are actually just have to, is there a chance we're going to have to do it, or we have to do it for the numbers?
They could.
Given or being able to read more.
Yeah, so you're going to do questions where you draw the graph when the equation is given, or where they give you the graph and you must find the equation. But we will practice all of that.
We would be left with like a variable. We won't be left with the variable.
I'll show you some questions that they sometimes ask in finals where they say this, but they usually do that with cubic graphs, which we're only doing next year, but where they just say A is positive, P is positive, Q is positive, draw a graph that could be like that.
Okay.
But we'll get to that later. Yeah.
I must just jump in.
Mhm.
Are you preferring standard for
You complete this way, but we're gonna practice that. We haven't done an example yet. Okay, so don't worry about that now. Guys, let's just quickly write down the last few things, please. It's not half past yet. Why are you packing up? For the x-intercepts, sorry, let's put an S there. Again, you're going to make y equal to 0 and solve for x. And that will give you your x-intercept. And when you do that, you're going to get an equation that looks like this. So a bracket x minus p squared plus q is equal to 0. Now, guys, from here, obviously, you can't factorize, right? If you have something that looks like that, you can decide, do you want to multiply that bracket out, simplify it, and then factorize? Or I'm going to write down step by step now how you could get x on its own. And this is actually, yeah, I think we might have done this at the beginning of the year, something similar. You're going to move whatever this number is to the other side, and the sign is going to change, right? So you're going to have a x minus p squared will then be equal to negative q. So whatever that number is, you move it and the sign changes. Then you're going to divide that by a, which is also going to be a number. Guys, I know it looks quite scary when it's all written in terms of variables, but all of these variables will be numbers. Okay, I'm just writing down the step by step how you would solve that. What is the opposite of squaring something? Square rooting, but remember plus or minus square root, right? So it's going to be plus or minus the square root of whatever that number is. Now, guys, I know there's no such thing. Well, I know you can't work with the square root of a negative number, but this might not be negative, okay? Remember, these are just variables. And then what are you going to do with that minus p? Plus on the other side, hey. So I'm just going to write it like this. X is going to be p plus or minus that square root of whatever those numbers were. Okay, so that's how you would solve for x in that case. It looks Much scarier than it is because those will all be numbers. Okay, you're not going to have a Q and an A and a P like we have there. Okay, guys, I want you for Wednesday to draw 2 graphs. Only 2. I'm writing them down. So homework for Wednesday. You're doing your test tomorrow, but on Wednesday we're carrying on with this. You are drawing y equals, sorry, I'm just trying to find one that is not bad now quickly. Negative x squared plus 4x plus 12. You're doing that one. That one is in standard form, so you're going to follow those steps. Number 2, you're going to draw y equals x plus 2 squared plus 2. You are drawing just those 2 graphs for me for Wednesday, please. All right, guys, email me if you have any questions for stuff that you're studying this afternoon. Okay, thank you. You can go. One of these. Oh, yeah. Awesome. Yeah.